Speaking of land issues, I mean, basically, how safe is Tokyo drinking water? Do you have any information about that?
You might have more information on Tokyo drinking water. It's below those levels of 10, as far as I know. Well,
I think occasionally we find, again, keeping in mind that the detector systems they use are very, very sensitive. They can detect very, very minute quantities. There is still some cesium occasionally detected in the Tokyo area in these in drinking water. Of course, no iodine 131 since 2011. Of course, no iodine 131 since 2011. Of course, no iodine 131 since 2011. Of course, no iodine 131 since 2011.
It's November the 2nd, the 3rd. Dana, get with the program. 2015. I'm Dana Durnford, also known as nuclearproctologist.org. And you can find my videos and Fukushima presentations, and you need to, at Beautiful Girl Boy Dana on YouTube. And so this is part 2 of a 5-part series of the Temple University, Japan's campus, with Ken Busler, whatever you want to call him, from Woods Hole Oceanographic Institution, and one of his little pet lapdogs, Asby Brown. Now, I would say Ken uses Asby to wipe his hands on after he eats pizzas, but outside of that, Ken is his own maniacal, twisted, demented little person. And so we've already established that a few days ago. But today we got a rather interesting interruption into our normal routine. Yeah. We got some pretty bizarre... And let me make sure I get this right, because we live in a bizarre world. And let me see, make sure I get the right one the first time. We'll never know till I click on it. That's not the one we're looking for. So there's this one here. Canadian researchers targeted by a hate campaign over Fukushima findings. Now, I know that you might be saying to yourself, hang on. And this beauty from Jay Cullen, of course. We're not at risk, but he is. Canadian scientist gets to death threats over the Fukushima findings. What findings? You never found anything. Canada's spending mobile radiation measurements in the same spot that guy was to in Victoria until further notice as a radioactive cloud was looming. Now, they suspended it to the public, but they kept recording it, allegedly. But that was because it got reported in August that Vancouver, Canada radiation tests from Simon Fraser University showed 131 times, 100 times above the drinking water limits. So the drinking water limits are, iodine was, what is it, 9 becquerels or something, the Canadian drinking water standards? We'll look at that maybe later. So you're talking that whatever was there in iodine 131, everything else was there. It was emblematic. These are all one and the same coming. These have electrons attached to them from the chain reaction. So they're no longer from nature. Right. And so keep all that in mind as we talk about Jay Cullen for a couple of minutes. And this is important. You got to love that headline there, that tweet as it happens from CBC. We're not at risk, but he is the Canadian scientist getting the death threats. Now, if Jay Cullen was getting death threats, we you know, I'd be in jail most likely, and so would a lot of other people. Yeah? And so, come get me. I'm right here, look. Right here. Just point the spotlight onto me. I don't care if it shows me in jail. Meanwhile, now this is going to become shocking to everybody that I'm going to show you over the next few minutes. And then we're going to jump back to his partner in crime, Ken Buechler, and Asby Brown at the Temple University in Japan's campus, charading the entire world. So let's play a clip recently of Jay Cullen claiming that he was on a boat where hundreds of thousands of dollars of equipment was hanging over the side of it. This is on the Weather Channel. And I'll get to the point after, trust me. I'm going to show you both videos. And so the first one, he's doing an interview. He's explaining what he's doing that summer by Skype. It's a bad recording, but we'll break it down for you real quick. And
we're funded by NSERC to be part of an international program that's called GeoTraces. And the goal of GeoTraces is to measure chemical tracers, trace elements they're called, in isotopes, to help us understand better how the ocean works. We're in the Arctic this summer. The short story is...
So he wasn't looking for Fukushima radiation all summer, but he's the spokesperson for all of Canada. He was out studying natural radionuclides, couldn't care less about the man-made ones that inundated Canada 100 times. 100 times. But let's keep going on that one.
The ship was working in the middle of the Beaufort Sea, really, about 240 kilometers away from the ice edge. And when we had equipment in water, we put an instrument package over the side of the ship with a synthetic cable, a cable that's not metal, because of the nature of the work that we do, so we don't contaminate samples. And when it was about 3.5 kilometers over the side, these three bears swam up, a mother and two roughly 2-year-old cubs. I'm a chemical oceanographer, so when I saw the video, I was quite surprised and astounded, and I contacted a polar bear biologist.
He saw the video, but he claims he was on the ship, see? And he didn't run outside and look at the bear, but I'll show you the video after. You'll find that really odd, but we'll get to the punchline after. Hang on.
Named Andrew DeRoche, who works at the University of Alberta.
But let's just think about that for a second. He saw the video, so he immediately contacted Andrew DeRoche at Alberta, a biologist studying polar bears, because polar bears don't exist anywhere else. But he never ran outside and looked at it himself for some reason, and he makes a point of that. But why would you care that a bear came up? How did that become news? Why was that important? These are questions you got to ask yourself sometimes. And I got some answers coming up.
And when he looked at the video, he seemed to think that the bears didn't really seem distressed, but that they just seemed sort of curious, that they wanted to know.
He didn't think they were stressed. Well, why would you think they were stressed? Why would you say something like that when you say the entire Pacific Ocean is perfectly fine, everything is hunky-dory when all the species are missing on the coastline? It's a really interesting question.
What this black cable was, and one of the ways that polar bears explore their environment is by biting things. And so,
wow, no. Well, I mean, I know polar bears don't got thumbs, dear moron. But I'll get to that punchline.
It's quite nerve-wracking for the scientific crew to see their tethered instrument.
Yeah, this is really interesting. They're building a fable here for some reason. I couldn't wrap my mind around it. But
potentially becoming untethered. We're funded by...
Okay, here's the beer. Polar bear, the cutest thing you ever did see. Enjoy this particular one. Go, go, go. No! Go away. Now, see, what's really interesting about that is I come from a place where they have polar bears. And if you lower food over the side of it, you can keep the polar bears alongside the boat forever. Just keep dumping it underwater or lifting it out of the water. But if you dumped it under the water, the bears will grab onto that line, right? And they'll try to pull on that line. That's okay. But anyway, why is that important, Dina? Okay, what I'm going to show you now is difficult. But a couple of weeks before that, and then I'm going to show you another picture a couple of weeks before that. And so this first picture coming up is really difficult of a polar bear to look at. It's more than difficult, but anyway, let's have a look at it. So this was several weeks before they put out that charade. Okay, here's another picture coming. And this is from several weeks before that in a different part of... These are from Norway. These guys were up in the Antarctic, right? And where the polar bears are too. And so these pictures that are absolutely frightening, because I've never seen a polar bear like that or anything close to that. But anyway, these pictures were taken by famous photographers, and this never got no traction at all out there in the medias. But we know how the radioactive isotopes travel and how they kill the animals' food, and how the seals, 10,000 seals in one island alone was found emaciated and dead and everything else. And that they are starving down there. And that as you go down that road like I did last night, and that's not what we're here to cover today, but we're going to have to do next week on Jay Cullen. We're going to have to blow the lid off his charade and his game, right? I mean, my goodness, hang on a second. Now we can't criticize Jay Cullen anymore. All you got to do is do a story and say Ken Buechler or Asby Brown or whoever the flavor of the year is or month or day is being death threats, and no one's allowed to come out and critique or criticize them. It's a frightening prospect. Not only that, but the Globe and Mail, if you go over and you look at any stories on Fukushima, you get uranium companies, uranium shares, uranium stocks, and uranium. They're 100% pro-nuclear, and then the comment section below that is just copy and paste from the pro-nuclear rhetoric. It's shocking. It's a 100% construct. Just like this story is 100%, and it's about covering up these emaciated polar bears because they got nothing to eat. Shocking video today. And I was tempted to come out this evening and do an entire stream about this, but we got to deal with the abusers and everybody else. So we're gonna just for a quick second run over, make sure the stream is looking hunky-dory, stuffy thingy. I'll put up that other one so that way if there's any comments. 11 minutes and 8 seconds. Yeah, you having a problem with the audio? Jimmy Joe, of course. Let's run over and make sure we're streaming okay. So I can hear the audio on my side. Looks okay. And so was it the picture? So everybody was yelling. And what do we got here? They're starving, emaciated. So how far was the audio screwed up? Was it just a polar bear? Or... Okay. I'm just trying to catch up. Adam says it's good. Okay, Adam. Thanks, buddy. And that was some horrible stuff. Yeah, I know. Tell me about it. I agonized this morning. Should I just come out this evening? And I probably will. Come out and bash it again. I've been looking into it since that article showed up. That's their way of trying to stop dissent or any kind of conversations about this, right? And so we're back on Temple University, Japan campus, part 2 of the scumbags, puke bags. And so we're going to jump into the video where we kicked off yesterday. And so get out your puke bags and your buckets. And here we go again. I got no idea what that one is. Hang on, I better check. What the hell is that one then? Hang on, I'll get it. Okay, I got. Oh, that's what I done. Okay, Dina. Here we go.
When I saw this data, downloading PDFs every day, looking at it, it became worrisomely high. These are levels that certainly unprecedented in my experience, and you can predict possible effects directly on marine biota swimming in those waters. What this was is some of the cooling water that's being applied heroically and necessarily, but getting into the ocean because of leaks in buildings and cracks. And you might remember some of the news, but there were things like a gusher of water coming out that had to be stopped.
Wait, now you said leaks in the buildings and cracks? Just let me remind everybody, and I'll get the whole thing up. Let me remind everybody what these buildings actually look like that Ken is alluding. Got some cracks into them. Yeah, this is Unit 1. Put a Kevlar sarcophagus around it. It's in there. It's 100% meltdown, melt through, melt out. It's 3 times the size of Chernobyl. Chernobyl stopped after 10 days. This is Unit 2, the same application here. And now we know for sure all the fuel in the reactor is gone. Nobody knows where it's to, allegedly. I can tell you where it's to. I can give you a pretty good idea on just about anything here at this stage of the game. This is Unit 3. You can't wrap your mind around that. Nobody can help you. And same thing with number 4. If you can't wrap your mind around it, that's wrecked. And that, yeah, there's a few cracks in it. Okay. Yeah, Ken. Yeah, okay, Ken, you were right. I mean, when these things blow up, they usually get a few cracks in it. It's just the way it works, right? Can you imagine if that was your property and that happened to it and you were driving down the road? Would you say, honey, I think there's probably a few cracks in there somewhere? Well, Ken did. Here we go. Let's keep going anyway.
You plug the hole, and what happens is...
Oh, you plug what hole? I got to go look at that. I got to make sure we're on the same page, kid. I'm just worried that, that everybody out there might misinterpret what the hole was you were talking about. Those holes. Plug the hole. They plugged a hole. Yeah, Mister. It's just. I'm just gonna leave that page there because we know that's gonna keep popping up with Ken talking, right? There's no way around this.
Going down. And so this is TEPCO data. So this is June 1st, 2011, and they had gotten back down to these levels about 10,000 to 100,000 in the unit of a becquerel.
Yeah, because they plugged the holes. Yeah, hard case, man. Let's keep going.
Cesium per cubic meter. It never went down to 0. It didn't go back to those levels that were there before. Cesium-137 has a 30-year half-life, so this isn't radioactive decay. This is dilution in the ocean, right? You put something in the ocean, and you start mixing in cleaner water around it. You expect concentrations to decrease. But we knew, the Japanese...
Yeah, you expect concentrations to decrease, but it's spread out. You can't get rid of the isotope till you put it back in the sarcophagus. It's not going to be just turn to fairy dust. We expect dilution. And so all the little fishes can get their doses, and all the humans on the planet and in the ecosystem, all the creatures and everything out there can suck it up.
Japanese knew, TEPCO knew, everyone knew that it hadn't stopped being a source back in 2011. It was still continuing to.
Yeah, because it looks like that today. That'll never change. Oh, yeah, they tore the top off that. Go back and look at the pilot episode. There's a link below, and it'll explain Unit 1, 2, 3, 4, those first couple of episodes. You'll see. Yeah, you'll see. Ken won't show it to you, but you'll see what we're talking about.
Release cesium, and I'll extend this out to today, into the ocean.
Just a reminder, there's a couple of thousand long-lived ionized radiated elements that are created by that chain reaction that we should be talking about, but Ken refuses to, of course.
Should we be worried? Well, I'm going to put it in a different way in the next slide, but basically there are limits for operating a nuclear reactor in Japan, about 90,000. There's a drinking water.
But that doesn't mean that it's safe. That doesn't mean that's acceptable. That just means that a handful of people said, we'll do whatever we want.
Understand it's about 10,000 or 10 becquerels per liter.
Potassium 40. And 10,000 per cubic meter is what they fudged that to be legal. Man-made stuff. So they just married those together, right?
We're familiar with that unit. The way I kind of look at it is up here, I'm concerned about direct effects on marine biota. I'm going to show a little bit of seafood data, not too much, but that's where you might have a concern about internalizing cesium and getting exposed because of your consumption of seafood when fish are swimming around in waters that are this high. And so there still is concern, levels 1,000 to 100,000. And to this day, now, this is one I had to grab off the internet, so we aren't my units. That's one.
This is something you had to grab off the internet. You know why? Because he's just fudging it as he goes along. Here's what when he came on board Fukushima, his original statement.
So, well, this event happened. I had actually moved out of this field. I was looking at radionuclides in the ocean, but more for climate studies, nutrients. But when we heard...
Now, was that me or was that just fudged up? And how would that get fudged up? How the hell did that I played yesterday and the day before get fudged up automatically? Was that fudged up on your end? I'm going to come over and check. Hang on. Yeah, let's see. Was that fudged up when Ken was explaining his original history, folks? Let's come over and check the comment section here. Yeah, it was screwed up. I can hear it on my end. And the chat room disappears. Oh, there it be. By the time he gets that message now, I'll be back to the program. Because I heard it, so I'll jump back in so we don't lose the stream. We got to watch these streams. Nothing duct tape couldn't fix. Okay, let's keep going. We got to.
Here is equal to 1,000 on the last graph, becquerels per cubic meter. I'm showing this to show both the peak. So right now, the blue is cesium-137.
Remember, he just grabbed that off the internet.
The red is cesium-134.
The world's most authority gets all the media attention out there, all the institutions, all the universities.
Monitoring site T1 is, again, very close to the reactor, equivalent to that last graph. But this now takes us to August of 2015. And, you know, they're basically flatlining here around 1,000 per cubic meter, 1 becquerel per liter for cesium-137. 134 has a 2-year half-life, 50% disappears because of its radioactive decay, and so it will be dropping now by a factor of 2 because of this radioactive decay process and by another.
That's assuming there's nothing coming out of there. That's assuming that it's not into a chain reaction. Chernobyl stopped after 10 days. That's why they got a sarcophagus put over it, right? And, you know, it took them a long time. They're putting another one over that one now. But Fukushima didn't stop. They don't know where the cores are. They can't get in there. You don't see... Like, he was at Chernobyl, but he's not in Fukushima. He was at Chernobyl for years, but he's nowhere... He never got... He's in Japan, but he won't go near Fukushima itself. On a boat offshore, allegedly. No one can believe a word that comes out of his mouth. And as you watch these videos, you'll find out that's very clear.
Factor of 2, 4 years later. So that one will always now be lower. But you see a lot of variability, and we'll get into some of the details and causes, but we're still kind of at these levels here that, you know, if I had to put them in the simplest terms, and this might be too simple, I just made this up over the weekend, but if I had...
Just made it up over the weekend.
To say in a becquerel per liter, where I'm concerned, above 1,000 per liter or a million on my first graph, then I do have evidence in laboratory studies that you might have direct impact on marine biota.
Okay, that's enough of that for a second. Hang on. Dr. Raymond Gilmet, killed beagles, dogs, and beagle puppies for 35 years at the Loveless Respiratory Research Institute. This study was on 144 dogs. And started the second sentence. Death started to occur 1.5 to 5.5 years. 4 years after exposure. Tumors of the lung, skeleton, liver. Accumulation begins 3 years after, or occurred beginning after about 3 years. Bone tumors in 93 dogs. Most common cause of death. Most common cause of... These are not shitty little woods hole, crappy... Nobody knows what the hell they're talking about. But here, look. You know what that guy's talking about? Do you get what he's saying there? Can you work that out on your own? Do you need me to explain this to you or anybody in the academic community or the Globe and Mail or Absby Brown? Do you need to explain that to you? How come you don't mention that? How come you're not capable of even recognizing that exists? Because that knocks the shit out of everything you've ever said and will ever say. Makes you look like a moron. And Dr. Raymond Gilmet, you can go find all of these studies, 94 of them. And what Ken is talking about, all of those doses are much more than the dogs were getting. Everything Ken is telling you. And he's not telling you nothing. In the context of what really happened there and really is going on. And you can see it in all my episodes up to episode 11. Back to my short videos while we're waiting to get our new computer, or the old computer back. Because we got hack number 9. We're going to try to salvage it. Because of all the software on it to do this. I'm only using a free version to do this here today. And so we're forced to do let's just keep going.
And swimming those waters. You get below that, you can't measure those impacts on marine organisms. You put them in an aquarium. But I can be concerned about eating seafood and fish swimming around.
That is pure nonsense. Right? Studies by Dr. Raymond Gilmet supersede anything he could possibly dream up. And like he told you, he'd come up with that one over the weekend.
When I get above this level, because 1 in the water translates to about 100 in fish if they're in full equilibrium with
and he grabbed the picture off the internet.
Fluid that they're swimming in, and 100 becquerels per kilo is your limit for seafood consumption in Japan right now. 10 is this drinking water limit, so down in here is kind of the green zone when I think it's very safe. You have to watch out. It tries not to use the word safe. The risk is very, very low because safe is a relative thing. So the risks down here are something that I'm not concerned about in terms of swimming in that water, drinking that water. Of course, we don't drink seawater. How high are they this month? Well, this is September.
And you like how they got this on a weird angle? It's not like they don't know what they're doing. This is what they do for a living. They're at a university. They know the camera is supposed to be pointed right in. Everybody's sitting in the rows know that. And everybody's probably wondering why is it, well, not really, because everybody there in that audience, except for a handful of people, appears to be part of the game. You don't hear anybody gasp in shock when they lie.
Anyway, and in September, you had a lot of rain. And Nami, I took this over the weekend and made a plot of how much rain had come in. 80, this must be a million.
And so what he's telling you about how he done all this the weekend and he grabbed this yesterday and blah, 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 is where he went down there, he met up with Asby Brown, they gave him the new stuff, and they walked him through it, and they asked him to incorporate it in there so the bosses would write them a paycheck.
Meters per day. Awful lot of rain came in. There's a monitoring site right here that automatically just pumps out data, the quality of which I'm less familiar with, but it's an automated system.
Right, and they power wash those spots and they dig up the soil all the time around them. That's been reported on these reporting stations that are supposed to be.
Sodium iodide detector, and what you see, we're back to these units of becquerels per liter, 1 here or 1,000. Is that before the rains, this was down really below the detection limit. It starts to go up after the rainfall. So this is transfer.
And so that was part of that construct. Let me play a couple of short clips for you. So he's talking about cesium-137 in the watershed. This is Asby Brown.
Keep in mind is that cesium in its various chemical compounds is water soluble. So it goes with the watershed. It goes where the water goes. And what we're seeing is, correct me?
Almost. On the freshwater side, it attaches to clay.
Right.
And so it's not as water soluble. That's why it's 80% coming down on particles, 20%. When it reaches the ocean, because of the high salt content, it becomes more soluble and ends up being different. Strontium-90 that we've mentioned, on both sides, salty and fresh, moves with groundwater very rapidly.
Right, and so there's 100 times more strontium-90 than there is cesium-137.
Very low accumulation of sediments.
Right. But nevertheless, what is actually coming out of these river mouths into the ocean kind of is stuff that was deposited at one point
On
in
land.
mountains, in forests and other parts of the land environment that gets into the watershed and then goes to rivers and creeks and lakes and ponds, et cetera, and eventually makes its way to the ocean. So this is the watershed is this important transport system for this cesium.
Yeah.
One
Okay.
valuable, and I took an opportunity to meet him at a conference in Tokyo shortly after that, and so we sort of stayed in touch. I guess another takeaway from today's talk was that this cesium is going to be very persistent in the offshore environment, certainly off of Fukushima, and we're talking about decades. We're talking about not 5 or 10 years, we're talking about probably decades based on the half.
Based on the half-life. Okay, so he gets a really good handle on that. Now, when somebody asks him a question is, the drinking water in Tokyo, which is a lake that's filled up with the forests and the mountains and the estuaries and the streams, is that safe to drink, he says?
Hi, thank you for your presentation. I was wondering, speaking of land issues, I mean, basically, how safe is Tokyo drinking water? Do you have any information about that?
You might have more information on Tokyo drinking water. It's below those levels of 10, as far as I know. Well,
I think occasionally we find, again, keeping in mind that the detector systems they use are very, very sensitive. They can detect very, very minute quantities. There is still some cesium occasionally detected in the Tokyo area in these in drinking water. Of course, no iodine 131 since 2011, but they are in the 0.000 range. In terms of becquerels per liter, so it is very low, what we'd call really trace levels. So I personally, I have no problem drinking Tokyo drinking water myself.
So, Ken finds it offshore because it come down through the mountains, through the streams, from the forests, through the lakes and estuaries and rivers, and through all those communities, through all their drinking water, and that it lasts for decades and decades in the ocean, but not on land, apparently. But yet Ken told him that it gathers up in the soil and the sediment and everything else. But they can only find... So Safecast is thoroughly compromised. That's what this is all about. Safecast is no longer to be trusted, and they got to get rid of that guy to even try to come back with some kind... But I mean, there's so many of these people, as you'll find throughout this 5-video series, that are going to ask them questions, Safecast questions, and this guy is a representative, and these are scripted, and so we got to assume the whole thing is rotten, and these are very rotten apples. These are rotting everything around them all the time. Let's get back to Ken.
from land to the ocean of additional cesium. I hope I said that. This is cesium-134 and 137. The red is...
Just remember, it comes through the mountains and streams, rivers, lasts for decades and decades, and there's none in the drinking water, Tokyo.
37 to the ocean, up to a number of about 3 on this slide. There was a second rain event on the 17th of September, and an increase here. Whether this is truly a dissolved form of this compound, so moving just with the water, or resuspension and sediment load from rivers, for example, since in the port, I think it has to be more related to...
And like they're burning it in the incinerators. They're digging it up out of the prefectures and taking it to the incinerators and other prefectures and burning it. 300,000 in a kilogram. And they're doing it throughout Japan, constantly. And so, not counting the... Now, the rivers themselves were highly contaminated, will continue to be contaminated. The pollen in the summertime is contaminated. The insects that are coming up out of the water are contaminated, mutated. Let's keep going.
Water itself, but there certainly were increases here. No data broke down right when you really want the most coverage. But
now remember, they jimmied this together over the last couple of days, some pictures from the internet and graphs that they just made up, and he's pretty smooth.
This type of thing tells me that it is variable and it will increase after heavy rains. We're well below the standards that they're allowed to have, up to 90 in these units, and we're here down at 2, 3, and 4. Drinking water standard, 10. But still, lots of variability caused by natural events such as rainfall. unusual rainfall, but still controlled, and that's what's driving, and we'll get into groundwater and fluxes from the land to the ocean in terms of numbers in a minute here, but lots of variability. So it's hard to say day to day that there aren't going to be some variations on this type of scale.
Now, he's 90%, 99% of the time, he's talking about coming out of Fukushima's surrounding little spot there.
So this is why we go back. I've been coming back at least once a year with my group, and personally sometimes twice a year to take samples.
Yeah, and he stayed down in Chernobyl for years and years and years.
Fukushima Daiichi. This is a cruise in 2013. We were here in early June is when we finally...
This is a cruise. You think about how big that ship is and how many people are on that ship, and he never mentions any of them. That's the PR firm, right? He never mentions any of them. And I mean, they need to report back to their bosses the real data. We will never even know there was data. There's always just a back wall. That's it. I can only find a back wall. Just like the weapons testing.
We got samples in 2011. There's more data than that. I don't want to spend a lot of time on this one, but just to point out, this says peak cesium-137, 815 becquerels per cubic meter. The size of the circle represents how much cesium is there in 2011. The circles get smaller in May of 2012. These numbers, the highest number we saw was 75. I actually saw 3,000 at a point down here to the south in 2011.
And so we know Tokyo, they were handing out bottled water for the infants. So it was contaminated. Now, it doesn't turn to fairy dust. It doesn't dilute and disappear. It doesn't become harmless.
We went too fast. 2013, we had 2 cruises, 45, 124, so slightly bigger circle. We had better access. We were kept outside the 30-kilometer limit. Here, we're getting within 1 kilometer. That picture I just showed you. So, of course, the numbers get high as you get closer, but they're not necessarily that different from each other. What I took away, and I actually made this figure on the cruise I was just on, is these numbers aren't that different from each other. You get a lot of variability in the ocean. So high in 2011, relatively constant since then, and that's similar to that input curve I showed you.
And so this is what he's talking about, is when they detonate it, and everything else is based upon that one detonation, and if it's nowhere near as much, it doesn't matter. It's insignificant according to these guys. So the only thing that really mattered, and that didn't matter either, of course, was the detonation. That was a high number. Originally there was a big number, huge, my goodness, run! But because they blew up, and then the emissions were still huge, but not even compared to the original explosion. I guess they're huge, Dana. I'll give you that. If you actually waterboard them 180 times, like Khalid Sheikh Mohammed, they tell you anything, probably, right?
You get the docks with those red dots leveling off, and there in these units, about 1,000. Is that what they leveled off to? It's lower in the ocean.
Yeah, coming down from the lakes and the rivers, the streams and the estuaries, and then they find it offshore. And there's nothing in Tokyo water. We're safe cash. We're like the best people on the planet. Look at me, I got a suit on. I'm somebody. He tweeted Jay Cullen a couple of days ago, as B. Brown did. Not hard to draw a few dots on these guys.
Seafloor sediments. You often don't hear as much about it because the isotopes of cesium tend to be more than 99% soluble. They pass through a filter and move just with the currents.
Well, try looking for some other isotope, Ken. There's a couple of thousand of them there. I know, Dan, a dreamer.
Fraction gets into the planktonic food web, sticks to clays, does settle to the seafloor so we can measure their distributions. There's been a lot of Japanese studies.
Well, I couldn't find any of the food web on the coastline of British Columbia, Canada. In a 5-month expedition, in 260 days, 15,000 miles of the coastline. The documentation is up at the nuclear proctologist, and we still have a ways to go. But just a quick reminder. Minder, what do you mind? Let me just explain to you how much of the coastline we really did cover on our expeditions, Ken. So all these earls are everywhere we went. This is only a fraction of what we actually covered. Like Langara Island, the very tip of Canada, we were there for 5 days. Actually, we were there twice. We done Queen Charlotte's twice. That was hell. And as everybody knows, I got caught in a hurricane, just endless troubles up there. We done all of British Columbia. We done all these inside channels, done all of those channels, done all of those channels right there. We done all of these archipelagos. We done all of these islands out here. We done all the inside of British Columbia. This is 460 kilometers long. We done that whole inside, much more than what you're seeing there. And we done the outside 2 different times. And the last time was 6 weeks going from the top of Bull Harbor, Cape Scott, and it took us 6 weeks to come down the coastline. And so we have a documentation of before and after of the coastline of British Columbia. And I'll just touch on that right fast for everybody. Sea life before and after. Hang on. It's not the one we're looking for. As soon as I'm here, let me boot into that one right fast. Dana. Sometimes I got to do that. And sometimes I got to look. Hang on. Almost there. Blurp, blurp. And so once again, these are before pictures of the Queen Charlotte's, one of the spots I was just showing you. But this spot is highly coveted because it has such a variety of species. And this is the same spot. And this channel, I've done an 18-minute video of it at low speed, underwater and above water. It's up at my site right now. That's the entrance of it. And that's just, so the picture I'm showing you, the original picture, the entire coast should look like that. Not just Louise Narrows. Let me go backwards. I'll show you emblematic pictures. These are, everywhere you look, it should look gorgeous, fantastic, amazing, incredible, just like that there. Instead, this whole channel is naked. And the whole coastline is naked. We documented that at the Nuclear Proctologist. This is some of that documentation. But that's what it looks like there on the shoreline now. And we'll jump right back now. But I just wanted to throw that out there. And that's what it looked like for millions of years pre-Fukushima. And since Fukushima, let me find a good one. See, this, as 14 years as a commercial diver, this is what I'm used to seeing everywhere I go. This is what the coastline looks like my entire life until after Fukushima. And after Fukushima, it's all missing. It's shocking, see? We documented this now, and we're producing a documentary, we're producing a book. We are blogging at Beautiful Girl by Dana on YouTube, thenuclearproctologist.org. We'll get back up to speed. But these are pre-Fukushima pictures. I'll keep going backwards. But so everywhere you looked, there was this huge diversity of life. It was an incredible diversity. And if you go look up Louise Narrows, this is what you'll find pre-Fukushima pictures. And we had a Zodiac like that one with a cabin on it. We still got that. And I don't have a right to sell that. That's got to go into a museum or something, the way I see it, hopefully. Or something that is fitting for what we done. And that is a collective of this entire planet. And the hopes and dreams will be behind that forever. That somebody went and done the moral and ethical thing and documented. This is what it would normally look like. That is Seymour or Louise Narrows. Hang on, couple more pictures. Well, anywhere on that coastline, this is what the pictures would look like. And that's Louise Narrows. And of course, now it's all gone, right? So it's shocking that people like Jay Cullen and Ken Buesler and Asby Brown are able to manipulate people. These are just iconic. And you got to realize it's very fast current there. And I never took the time to get really good pictures of it, a couple thousand. They're up at my website, thenuclearproctologist.org. And let's keep going.
Of that distribution, both close to Fukushima Daiichi and further afield, so we can add up how much is in there in total. One thing we see, these different colors represent different cesium levels, and so there's a lot of variability from place to place, even on small scales, the closer, harder you look. And you add up all of this cesium compared to all of those releases, and it's about 0.1 to 0.2% of the total, consistent with what we know about the chemistry of this salt soluble.
So the chain reaction of the reactors, I have a better picture to look at when I'm yakking, is consuming the rocks and the cement and the steel and the rebar and the earth and itself and everything around and everything that falls down on, and all the tremors are knocking all this debris that's dried out from 9,000 degree Fahrenheit temperatures down on top of it. Remember, Japan was extraordinary. It was traveling at 9,000 miles per hour. It hit Florida half an hour later. The whole country shook for 6 minutes. It was nothing you've ever experienced. It was the most unnerving feeling imaginable. A tsunami ran through 500 miles of the country at 600 miles per hour as it hit the coastline, and cruising at 100 throughout the country, taking everything with it and creating a 2,000-mile debris field off the coastline. The radiation continues to come out through the air, continues to come out because it's heated at such high temperatures. This stuff is way hotter than a forest fire, and the forest fire are big particles, thousands of times bigger than the stuff coming out of Japan. But you can put 2 million atoms on the head of a needle, you can't see it, but that's 2 million cancers distributed out. Forest fires and automobile pollution, much bigger, comes across the Trans-Pacific jet streams and corridors, and is well known. The model you're looking at behind me is just a short release from a single reactor. It doesn't include the melted reactor, the disappeared reactor, the ongoing constant cannibalization of everything around it being ionized and radiated. It doesn't include the fuel pools. It doesn't include the other reactors, 100% meltdowns. We've never seen that on our planet before. Let's go back to Kim Buesler.
Cesium, but it's going to stay there. This is not moving offshore very quickly. This is going to stay there over time. People have measured different locations over different times. This is 2011 to 2000.
Okay, I've showed the videos of Kim Buesler saying 2 Japanese studies within 1 month showing the radiation 1,500 miles offshore. Corrosion current travels at 5 miles per hour, 24 hours a day. 45 days later, it's in Canada and America's doorstep. A week later, it's updated. A year later, it was day after day after that of plumes coming across. The plumes never stopped hitting the coastline after 45 days. It came over in the jet streams in a couple of days. Well, let's listen to Kim's version. Why not? That's what we're here for, right?
2012 from Kusakabe and others. You know, it's very hard to see trends with time when there's so much variations on small scales.
And you don't put none of them into your model.
And we've done some looking at that, but you're pretty much...
Yeah, that's all you've done was some looking at it. And you're right.
Inventory here, small fraction, but of a big number. And that's the point of this slide. Said if you looked at all the cesium today, and this is a bit out of date, this is now in units of 10 to the 12 zeros, not 15. But the interesting...
Right, and remember, one of the most prolific isotopes is curium, because the rods have already gone through a chain reaction and spent fuel pools that caught fire, but because they were using reclaimed plutonium, reclaimed uranium, right, from missile silos, this was producing an unimaginable amount of curium isotopes. That's why we see the extinction event playing out on this planet.
To me, is the seafloor contains, say, out to 200 meters water depth. If you look at that box, oceanographers love to put boxes around things and look what goes in and out. So 100 of these terabecquerel.
Yeah, but you're a marine chemist.
You look at the ocean water itself, it's only 15. So we've switched around a bit from 2011 when there's much higher levels in the ocean before they mixed away.
Look, I'm having a cigarette put away. That's Canadian. That's CNTs. CNTs don't have 7,000 chemicals in it. So many people are brainwashed that if you got a cigarette, you must be mentally ill or evil. I'm having tobacco, not 7,000 chemicals. Go do some science of your own for a change.
Now where your biggest source of cesium is the seafloor itself, small fraction of a very big release that was over 1,000.
That was the point I meant to make. So originally it was a big release. We get that, Ken. We know that when something blows up, that's a big release. But then they melt down. That's why Chernobyl was bad. That's why they're still there. That's why they got a sarcophagus over. You were there for years. You only spent a few days over there at Japan. 3 times the size, 100% meltdowns. Chernobyl stopped after 10 days, was equal to 400 bomb tests. Hiroshima's. 400 after 10 days, but it stopped. If it lasted 20 days, it'd be 800 Hiroshimas. You can do the math. Now do the math on Fukushima and see why I'm talking the way I'm talking.
Times in those same units bigger. All right, so that's interesting to know. What's more interesting to me is to kind of put that box around it and say, okay, what's coming in the rivers? That number in the back is 0.2, about 0.8 water and sediment. It comes mostly down with sediment load.
They're dumping it into the rivers and the lakes and the streams and the parks and everywhere else when they decontaminate communities, besides the fact they're burning it in incinerators throughout the country non-stop. Ken? That's what I mean, right? Like he doesn't, that's why we're here, because he doesn't put anything in the models. Just whatever the fictional construct that the nuclear industry imprinted into him. And he's like,
So say about one of those units coming in being added to this 100, not a big number. The plants themselves, there's been several estimates. The most commonly cited is about 0.3 terabecquerels per month, less than one, coming in from Fukushima Daiichi itself. So there's as much coming down the rivers as are coming out of that power plant. We go back by measuring what's in the ocean.
Oh, right, right? You're going to go for it. Might as well go for broke. Now the rivers are melted reactors, huh? Okay, yeah. What about the spent fuel pools? What was up that river? Was there a nuclear plant up there that melted down? A tsunami come in you didn't tell us about, Ken? Is that what it was? You got to realize tsunami took out the whole coastline. All the reactors on the coastline, after about 2 hours, here's a clip for you of the media talking about it a long time ago.
I would say this will not reach the level of Chernobyl. And Chernobyl was a lot of radioactivity.
Yeah, Chernobyl, 1/3 the size. Chernobyl, 30% meltdown. Don't mind that lie. But he does give you a really good tidbit in a second. Chernobyl stopped after 10 days. Chernobyl was equal to 400 Hiroshima bombs.
100 times Hiroshima and Nagasaki combined. Now, 3 Mile Island...
100 times. Yeah.
Be more in the realm of where this could go if the safety systems fail. If they lose power to those to that reactor or to any other reactors past a few hours from now, you might reach a 3 Mile Island situation.
Oh, what's this? If a tsunami comes in and takes out 500 miles of the coastline, you might get a whole bunch of melter reactors. Or any other reactor, right? Yeah? Yeah. Let's keep going.
We're trying to make new and more refined estimates of that as that changes over time, as that changes with rain.
Hey, didn't they have a tsunami down there do exactly that? I gotta look that up. Hang on.
We just published a paper on the transport of some of the sediment offshore. We measured that. That's also a pretty small number. A lot of this gets back to my conclusion that, if you have about 100 of these in place, you're adding about...
We don't want your conclusions. We want the facts. Like everything into the models. Not see everything's a conclusion. Got it off the internet yesterday, found it today, looked it up the day before.
One a month, and you're losing about one a month. You're not going to see a big change. But this is the type of information that helps us understand.
Now, if you included all the burning debris throughout the country, if you included all the dumping in the rivers, if you included all the fallout that went out throughout the country and gets washed out every time there's rain or a typhoon or snow, or even a little tiny bit, if you included all the 3 melter reactors, if you included the spent fuel pool, if you included anything besides cesium-137, I probably wouldn't be screaming.
How long will the seafloor be contaminated in terms of other issues like maybe benthic fish, things you might be consuming and stuff like that? So this is a type of...
You're contaminated just like that ocean till the end of time, Ken. Don't worry about it.
It's painstakingly hard to get, takes a lot of sampling, and many scientists in Japan are working on.
They got a secrecy law, kid. Wake the frig up.
Most people at this point are kind of bored because they say, well, what does it mean for me? Well, that usually means seafood and fish. This is just as simple as we could make the story in that pamphlet.
Yeah, I bet it is. You're not going to show them a picture of the reactor. I'm sure you're not going to show them anything else.
I really want to dumb this down too much.
Don't want to dumb it down too much, so use the cartoon.
There's a whole marine radioecology field about the uptake of radionuclides by fish. They're either getting it from the...
So the phytoplankton are being eaten by the zooplankton. The zooplankton's eaten by the krill, and the krill is being eaten by the... There's no herring left to eat them, or anchovies, or squid, or mackerel, or sardines, so I don't know what they're being eaten by. There's no birds left out there for them to be. There was none of the phytoplankton, which is the base of the food chain, the oxygen, the carbon sequestering chains. When I was out there for 5 months in the Charlottes, waiting for it to show up, there was no migratory birds and mammals and animals, and who cares?
What they eat, or by the water that they take in as well. And different fish have different sources. Bottom fish tend to be.
Fish absorb water? Do humans absorb water when we get baths and showers and everything else? This is a question that somebody somebody better get the friggin' answer to that one. That one got me thinking. Hang on. This is because now in Canada, the Drinking Water Health Canada standards has included all these artificial radionuclides, 7,000 becquerels a litre. Now, do you get a bath in a litre of water? Because you're going to absorb at least 3 litres. That's 21,000 becquerels for 120 years in your body. It's got a 12-year half-life. Not to mention the strontium-90 per litre you're absorbing through your body like the fishies. No, I guess humans don't absorb it, right, Ken? No, it's just fish, Dana. Better start kicking. That's going to get 6 minutes left. Dana, shut up, Dana. Let him talk.
A little bit higher. They seem to be getting more cesium from some of their feeding on the seafloor, the demersal fish. And they're getting...
Yeah, because there's nothing left there to eat. They got to eat it and dig on the floor looking for something, like those polar bears.
All of those sources of fallout, runoff, groundwater, and the seafloor. Cesium itself, this is another very simple lesson, and you've probably heard, but cesium behaves like that potassium. It's a salt, goes through our system very quickly, goes through fish very quickly.
Even that's true. What about the other 2,000 isotopes? It's not true, though. I mean, it's not true. He talks about it later on how he went and got fish, but not for eating, is caught off Japan. And he tested before anybody eats it, and he recommends that, right? But oh no, it goes through them.
A couple of months is the biological half-life to lose half.
30 years, kid. But he can't tell you the truth anywhere in the entire video.
For the cesium, you take a fish, and it's contaminated. You put it in a can. It takes 30 years for half of the cesium to go away. You take a fish.
Right. See how he just muddled all that together, and then he says
In a
that?
clean aquarium alive, and it takes 2 months to lose half the cesium because it's exchanging its salt all the time.
It sequesters into the organs. It sequesters into the bones, into the muscles. And then it does its damage immediately. It's popping the DNA, it's popping the chromosomes, it's causing all kinds of mutations in the larvae, the eggs, the sperms.
And so you're not going to see far-field transport. The fish, there was some tuna caught in San Diego, and they had about 40...
Tuna are way up the food chain. Like all the stuff that comes over here in these plumes, right? That hits the mountains and then washes back down to your lakes and your rivers, your estuaries, just like there, and it shows up down on your coastline, and then the fishery going into the shorelines, into that zone to feed on, because there used to be enough mussels to feed the entire planet in the tidal zones of British Columbia, Canada, sustainable. Not to mention all the other species that were there, just on clams and everything else. Let's keep going on that. We're running out of time.
Lower cesium levels because they lost that while they swam across the Pacific, the bluefin tuna, from feeding here.
They can't lose it, Ken, by swimming across the Atlantic, or everybody out there now be out there swimming across the friggin' the ocean, right? You got any ludicrous... So if I go hike across Canada, will I lose all the radiation in my body? If we have a mass migration across the country, everybody's okay? Huh?
To the coast of California. That happens very quickly. It's taken up in mussels and organs. Strontium-90, calcium mimicking, so its chemistry is like calcium in our bones. I'm sure a lot of you know this as well. These are very simple lessons, but I think people don't understand is the difference between them. That would have a residence time for years, potentially, than a bigger concern in terms of far-field transport of something, a fish swimming away, would lose cesium quickly and would hang on to the strontium in the bones. After Chernobyl, they weren't concerned because the Europeans just outlawed the selling of small fish where you would eat the bones and just allowed you to have fish fillets, which do not have the strontium-90 in them.
So that was the game they played. But it has all the other 2,000. It has curium and uranium, plutonium and americium, neptuniums, and all the other
This
buggers.
has some practical, actually, importance as well. The levels are decreasing over time. I published a paper a couple years after about the continuation of high levels between bottom. So,
look, Dr. Raymond Gilmet, he published 94 papers. I think I'll take his words. He was killing dogs, beagle dogs. Not that I like him or admire him, because I don't. He's a despicable shithead like you. But at least he had the balls to show that death from radiation occurred 1.5 to 5.54 years after it. Tumors of skeleton, lungs, liver occurred beginning at about 3 years. Bone tumors, 93 dogs were the most common cause of death. Lung tumors. This is 144 dogs. This is 144 dogs, Ken. I think his studies, 93 of them, kind of carries a bit more weight than your nonsense.
Fish, we're seeing the levels go down significantly near Fukushima Daiichi from over about half.
Look, Dr. Raymond Gilmet, he only gave it to him once. I'm having a smoke. It's CNT. It doesn't have 7,000 chemicals. It's natural tobacco. I always got to say it because the trolls will come in and they'll come in anyway, right? And attack me. Oh, Dana's having a smoke. I can't take anything he says, sir. He's crazy. Hey, he's crazy. Well, Dr. Raymond Gilmet, eh? Anyway, let's keep going. We only got a minute left.
Above the threshold of 100 becquerels per kilogram. If you take all the fish, and some fish were low from the start, this is down something like 1%. It's a small fraction. I haven't been able to go back into the literature. I'm not a fisheries biologist and look at which types of fish are still high. Presumably it's the bottom fish that were high.
It's anything in the ocean. This is distributed, and that's the end of the show. And so it's anything that's in the ocean. We'll come in and say hi to everybody. And these had meltdowns. We had major earthquakes, melt-throughs, melts out. They polluted the entire Pacific Ocean just on a single release. Just these models are only based up on a single release from a single reactor for a short period of time. It shows the whole ocean would be distributed out evenly. And so if it's ongoing, which it is, and constant, and there's actually 3 100% melter reactors, then the models you're looking at are like a candlestick, compared to what you see in there. If you put a candlestick in there, you wouldn't see it, right? But if you put all the other models in there, it would be it's just unbelievably shocking. And once again, they turned off it, they suspended telling you about it, they kept doing it. They moved it into Kelowna that week. They took it right off the coastline, moved it to Kelowna, and that was because when you look back, you find out they had discovered Simon Fraser University. There was 100 times, but we got 300 times examples. We got all kinds of examples of it falling out throughout the country, throughout Canada, throughout North America. And just because I show you this particular model doesn't mean that's the only model. I show many, many, many models since we've been at this. And so we'll come over and say hi, everybody. Good night. Good day to everybody. Put up that one. And it's just shocking that we got to do something like this. But I feel that this is really important, that we got to come out and push back against these critters, because these people are the most disingenuous, dishonest, creepiest people imaginable. And the stats today are people watch 17 minutes. Wow. 124 playbacks. Wow. That's pretty good, man. I'm not complaining. I don't mind. That's more than Jay Cullen's going to get. Unless he's out there, they're sending me death threats. So this is all a construct. That's what it all is, to try to give him pity because he's pushing out the polar bear routine and everything else. You can watch the beginning of the video, catch on to that. And so, no canned fish. No, that's right. Adam, they don't dump anymore. Now they pump it out to the sea in pipes. That's true, though. Gulf of Mex-Corex. Yeah, Woods Hole was the people who told us Corex was okay. The same naughty crew, right? Age of Fission is the 70s legacy, but it'll be our legacy that we put an end to this. That, if Jay Cullen thinks and Ken Buesler thinks that the heat is on them right now, they got no idea what's coming when people find out what they got done and what they were doing, and that these people were put out there and put on pedestals by all the media, and they came out and defended them and then mocked anybody who had any genuine concerns about it, and anybody that even said, well, I don't think it's like a banana, I don't think it's like walking in sunshine, I don't think it's like getting on an airplane because I read some literature and it says it's not. And so these people don't have anywhere to hide to. Thanks, Terry Ann, Candace, Adam and Cotton, Mickey, Albert, Chuck. I know Miss Milky was there, but I know how busy she is. Thomas Ackerman. That's right, buddy. Brenda. Those pukes. Used to drive truck for a short. And so that's what I'm saying is that what we're doing is actually necessary. We got no options. This is the part 2 of part 5 of Fukushima, Japan's radiation safecast, turning their back on everybody and their own friends, their own families, their own loved ones, their own communities, everybody around them. Everything they come in contact now is dirty and contaminated. And that how can they look their loved ones in the eyes, knowing the lies that they have created in that family to get their children to love them by telling them that they're genuinely nice people, that Asby Brown is somehow a normal person like me or you, or that Ken Buesler or Jay Cullen, an outrageous, outright, easily provable fabricator of information, a propaganda machine in every context of the word, is somehow got any moral high ground or a moral compass, is inexcusable and will come to haunt them forever. Yeah, time flew today, Miss Milky. Jan Brooks, you'll find links to a lot of these people below, my videos, and what are you doing? Yeah, well, I know, Mitch. What we're doing is what we're doing. And all the light goes on to me, but it's everybody that supports me and everybody that I know that the day is going to come, right? And I'll have to count on you. And I can. And that's why I can do the things I can do. That's why I can say the things with the justification and the green screen behind me to give you the documentation. And why it's so provocative is that they are now hardcore and trying to bury it. And so that means they're going to come after me and you and everybody else. They're already doing it, but now they're going to really ratchet that up. And they very well might, most likely will kill me and a lot of people out there in the near future just to silence us. Because what we see in Jay Cullen's story is emblematic of panic in an organization. It's emblematic of them feeling destitute and hopeless at this stage, and that they have to come out and jimmy up this. You go read the story, go through the comment section, you see there's no one there legitimate. You see that no one's there focusing in on death threats. They're focusing in on inundating people with the nuclear rhetoric of bananas and potato chips and airplanes and walking in sunshine and dental x-rays. That there is nobody there really truly concerned, and that the writer didn't even write with that style, or with those flares, or with that sincerity or honesty, and that he smeared everybody and equated them with alarmists when there's no way you can talk about the subject without sounding like an alarmist, and rightfully so if you talk about anything pertinent about the subject. It's another betrayal that the Globe and Mail, I can assure you I'm going to rise to that unfounded, ridiculously written article. And that when you look at the Globe and Mail, they're pro-nuclear. They've had Jay Cullen up there repeatedly, Ken Buesler up there repeatedly. They have no right to be putting out that story outside of a smear campaign designed in a desperate attempt to try to save Jay Cullen's reputation, which there's nothing anybody can do to save his reputation. He's the lowest form of life. He knows that. And getting up on CBC and other alleged prominent media is to put out his narrative is not going to help his cause, because that's a statement, proof of how twisted and demented he really is as this comes out. That's going to come back and haunt him. His words will come back and haunt him. Just like at the end of 2013, he said he didn't know of any melted reactors on the coastline in Japan. But if there was one in Japan, that would be something different. And he knew 100%. And that where he's fending ignorance and that he's innocent and that he's a good person for doing what he's doing is a construct to try to save his falling. Listen, he's making $360,000 a month, 600 samples, $600 a sample. He has everything to gain by keeping this show alive. Hugs for everybody. Yeah, the Fukushima panic is on, Thomas. And you'll find Thomas's links below. Hugs for everybody, Candace, Chuck, Ellie, Albert, Freak, Adam, and all the other people. I love you folks. Don't think I don't. It's just I can't get to everybody. Joe, Boder, and Silver Fox, everybody, Ellie, Amthers, Elaine, Miss Milky, yeah, Rad Chick, everybody out there for doing what they're doing. That's my heroes. That's what gives me my energy all the time. That's what allows me the latitude to dedicate constant, every waking moment to what I'm doing and just showing you the very factual information, the most important aspects of it, because we have tens of thousands of documentations on this. And so we have that freedom to show you choice information that is indisputable. Like there is nobody out there can show you as much as I show you in a single sitting. The story on Jay Cullen shows you nothing. I show you endless documentation. We're begging you to open up your mind and open up your heart and understand that what we're saying is real, what we're presenting is actual, and because that's true, and we have no reason to lie to you. Hugs for everybody. Take care, folks.
Speaking of land issues, basically, how safe is Tokyo drinking water? Do you have any information about that?
You might have more information on Tokyo drinking water. It's below those levels of 10, as far as I know. Well,
I think occasionally we find, again, keeping in mind that the detector systems they use are very, very sensitive. They can detect very, very minute quantities. There is still some cesium occasionally detected in the Tokyo area in these in drinking water. Of course, no iodine 131 since 2011. Of course, no iodine 131 since 2011. Of course, no iodine 131 since 2011. Of course, no iodine 131 since 2011.